Welcome back to the channel, everybody. I'm Trevor with Maker Experiment, and in today's video, we're going to be doing a simple project for a storage solution for the shop. Let's get into it. For this project, I'm going to be making a storage bracket for my Amazon Fire TV remote. The reason for this is I had a remote that originally came with the TV. My kids have been out in the garage. I have no idea where that remote went. It disappeared maybe the first week I got the TV. What I'm going to be doing is putting an actual bracket on my wall control storage. So I have a set place for this to go, because what happened last time is it was just on my desk. They took it, they had nowhere to actually put it. So my hope is by putting a dedicated space, we'll be able to keep track of it this time. The other thing is I just got an acrylic heat bender, so I want to try that out. So two birds, one stone. Let's see what happens. Here is the wall control panel I'm going to put it on. So the plan is to make a bracket that will fit into the slots. The current brackets have, if I can get this out of here, they have this shape on the back side of this. What I'm going to try to do is I'm going to try to mimic that and be able to make an acrylic one where this remote will just sit right here. So we're going to start out by, I already modeled the bracket itself, but I need to do this hook piece. So we're going to throw this into the laser, try to use the camera to trace it, and then see how close we can get. So let's start off with that. All right, this is how I set up the bracket to try to get an image of just this hook piece, just using acrylic underneath of it that's got a solid color to help distinguish the blue from that grid. So let's go over to the software and see if we can pick it up. I have the camera up for the maker. So what I'm going to do here is I'm going to go over here to my left, copy the background image. I'm going to then open Adobe Illustrator. And this is going to take a second. But essentially what I'm going to do is import this image into Illustrator and then trace it. And hopefully, well, I'll trace it first and then I will do a test cut to make sure it closely matches and will work for what I'm doing on a scrap piece of material. If it works, then I will actually take that design and add it to the bracket that I have designed in SolidWorks Maker. If that works, then we'll be able to actually print something. All right, here I am in Illustrator. I'm going to Control V to paste my image and lock that layer. I'm going to then start a new layer and then change my trace color. I'm going to make it red so it'll stand out a little bit better. And then I'm going to just trace the outline. So quick trace here. That angle might not have been good, so let's do that. Do that. Okay, so I have this one. Clean that line up a little bit. There we go. Come back down here. It might be kind of hard to see some of these lines. Frankly, it's hard for me to see some of these lines. And this will be like our first little prototype, if you will. And then I'll add a little circle here, like so. And then use the shape builder tool. Okay, I want to get rid of that. And oops. So we'll do this. Oh, there we go. There goes that piece. Do that. And see if this works. There we go. Not exactly what I meant to do, but it works. Okay. Give this little curve, little curve, little curve. So what I'm going to do is I'm going to send this back over to the laser. And we're going to cut this out of a piece of scrap. So I'm going to grab a piece of scrap material, and then I will see you over at the laser. So here's the initial one. That one slides in like so, and it doesn't really move. Now, my acrylic one goes in, it'll rest on that back side. Now, the thing I didn't do in the prototype is I didn't bring this down far enough, but it locks it enough that it'll work. So now I'm going to make a second prototype where I extend that and see if that will work better. And if so, then we'll incorporate it. In the process of prototyping, I made 3 different versions. There's version 1, which didn't have the little hook down. There was version 2 that had the hook down, but didn't, or I had too much space in between, so it didn't sit very well. And then version 3, which is really small, has the hook to help keep it in place, but I shrunk the distance between 2 areas to give it a better grip. So if you jump over to SolidWorks here where I have the bracket, so right here is the bracket itself. The intent of this is that the remote will sit in here. I'm going to actually make a new sketch, and I've already got, so I saved out the bracket design, or this hook design, as a DXF and imported it into SolidWorks. So I can copy it and then paste it into my design. So here's the hook. And what I'm going to do is try to line them up. I want to figure out a good spot for it. I mean, about 3/4 of the way up is probably sufficient. And then what I want to do here is make sure that they overlap, which they do. And I'm actually going to make them overlap from this front part here, because I think that will probably be the best spot, I hope. Yeah, we'll try this. We'll see if it works. So here, just making sure it overlaps. I'm going to, so normally I would constrain this, but the shape is kind of odd, so it's a little difficult to do that. So I'm just going to exit, make it a sheet metal flange. Come on. It has something with unstable geometry. So what's the unstable geometry? The hard part about bringing something like this over is you typically get something like that. I'll be back in a minute. I'll try to figure out what's going on. After a few different iterations off camera, just because it took a little while, I did make a version 5. So this was version 4. You can see that I eliminated this little step. Now, this still isn't perfect, but it will work for what I need to do. It's still a little bit loose at the top, but I don't have a lot of time left to figure it out. So what I'm going to do is I'm going to work with this one, apply it to the design. You can see here in SolidWorks that I applied that hook to both sides of my bracket. I gave it a little bit of a design flair just to make it so it's not just like a flat rectangle. We're going to take this and we're going to go to my drawing. Now I might have to make the sheet a little bit bigger. We'll make it a 1:1 scale. The size is going to be, we'll do 12 by 12, just so we have the real estate here. And then for the drawings, I'm going to delete this view, go back to my bracket, and I'm going to flatten it. So flattening it just makes it so it's a single flat layer, nothing's bent yet. If I go back to my drawing and I import the view, I really didn't need to delete the previous view, but a little late now. We will get, if I can find the right one, there we go. So this is the design. I'm going to make it a 1:1 by using the, well, it should be 1:1. There we go. The dashed lines I'm going to keep in here. You'll see why here in a moment. But essentially those are my bend lines. So we are going to save this as a PDF. All right, so I'm going to save this as a PDF. Then I'm going to take that PDF and open it in Illustrator. And that will give me my design. So what I want to do here is make my artboard the size of my bed, just because that's the way I like to do things. I'm going to change those dashed lines to a different color. Make those, I'll make them blue. And then the exterior one, I will make red. Whoops. Don't know why that ended up pink. Guess I selected the wrong color. There we go. So this is going to be my bracket. I'm going to vector score the blue so I know where to bend, and I'm going to vector cut the red. So we're going to print this. I'm going to use a piece of blue material. See if this works okay. I'm going to put this in the laser. So here's my bracket. Put it onto my material like so. The blue, I'm going to do a vector score. So I'm going to choose a very high speed for this. So I'm going to do like 30. The power, I'm going to do at maybe 5. Just because I don't want it to go through, obviously. The red, I will do the 8 speed, 100 power, and 100% frequency. This is on the Fusion Maker. That's a 30-watt laser. And then we will print it and hope I did this correctly. I want to take a quick minute to tell you about my membership called Lasers Made Simple. I have a free community that you can go to. It's linked in the description below at lasersmadesimple.com/community. You can get to know other laser owners that are looking to also grow their laser business, bounce ideas off of them, get information on how to design something or whatever it may be. We're all there to support each other. It's absolutely free. There is also a paid option at lasersmadesimple.com/membership. This has got group lives every month where I go through and I cover different topics like the Epilog dashboard or designing, laser business. Those are usually about an hour long every month. I also have videos as part of that membership. There are 10 of them right now where you can learn how to make 10 different products that you can sell to help kick off your laser business. You'll also get access to all of the pre-recorded group lives that I've done in the past. So again, if you want to check it out, go to lasersmadesimple.com And now let's get back to the video. I just machined the flat pattern bracket. So this is going to get heat bent into that three-dimensional shape. So I have the score lines here for where to bend. So let's go over to the heat bar and I will show you what to do. Here is my heat bar. This is the FTM, I think it's the FTM 24. I'll leave a link to it in the description, but I bought it straight from the manufacturer. So far it's been pretty good. So what we'll do is we'll sit the acrylic over top of this. The only thing I don't like about this heat bar is it doesn't have an on-off switch. It's basically a plug it in or don't plug it in. So we will sit it on top of there. Now I'm going to hold it a little bit, and then once it gets hot enough, we'll be able to bend it. Keep in mind I still have the plastic coating on here. I may need to take that off the next time. Before I get too far, let me grab a board. This will work. I'm going to use it as a straight edge, essentially. So once it gets hot enough, you'll be able to feel it bend. Now with thin plastics, it's going to be hard to bend. It's going to be hard to tell whether it's just bending because it's thin or it's bending because it's hot enough. It doesn't feel hot enough, so I am hovering it over the element. I'm not sticking it on top of here just because I want to see what happens first. My plan is to do the two long sides first and then do the short side last. This is going to take a little while, so we might just jump to when it is hot enough to bend. All right, I think that might be hot enough. So what we'll do here is come over here. I'm going to use the straight edge of this acrylic. Line it up with that score line, like so. Oh. Don't think it's hot enough yet. Keep going. By using this acrylic as a straight edge, it'll make sure that I'm bending it evenly across the whole thing and I won't get a distortion I'm not looking for. It does take a little bit, so be patient. Don't try to rush it. All right, I think it might be hot enough now, so let's try this again. Just trying to bend it evenly. And then once you bend it, you kind of have to let it sit to cool down for a second. So there's bend number 1. All right. I probably need to bend it a little bit more, so I'm just going to let it sit here for a second. And then just apply that pressure, kind of over bend it a little bit. And then let it cool down. Okay. Now we go to the other side. Again, just take your time. I can tell the heat bar is getting up to temperature. All right, now that's pretty good. So what we'll do is we will bend it. I'm just sandwiching it between the acrylic, so it might be hard to see, but all right. So there's 2 of them. I'm going to test fit this real quick off camera to see if it works. Good news is it works. So we'll just do this last piece here. This one I'm going to have to bend with the table because I'm not going to be able to fit this thicker piece of acrylic. Bend it. like so. Try to hold it down where it needs to be held. And then we're gonna let it cool off for a second. So just let it sit there. All right, here is the bracket. So if I spin it around, you can see the bent bottom, the bent sides, the little hooks I made. We're gonna peel off this plastic, which arguably I probably should have done before I got this far. There we go. There's the inside. Now let's do the outside. All right, and then for those that wanna know, I think this is about 16th inch thick acrylic. It's actually two-toned. It's silver, or clear on one side, blue on the other. That's actually one of those engravable two-tone plastics. I just didn't use it for this, or didn't use it for that purpose. So this should fit. Now the real test is to test it on the wall control. All right, we're gonna try right here. Just slide it in, slide it down. It does hold pretty well, actually. And then, real test. Ta-da! It does work. It's a little sloppy side to side, but I had to make it that wide because of the spacing of the brackets here. But if I take it out, I can take this off. I can move it around, say up or over, wherever I want to put it. And then it's locked in place. Drop the remote in. That is the custom bracket. Personally, I think this was a lot of fun. I will admit it's kind of frustrating at times when you're prototyping to have something not work the first 4 or 5 times. It did take me about 5 times to get the hook part of this right. I will say I nailed the bracket first try, so not too bad overall. I do want to point out that you don't need a heat bar to do this project. You can use just a heat gun to get it to work. I bought the heat bar to do other kinds of acrylic bending projects, and this was kind of the first real test to see if it would work the way that I thought it would. It is really cool. Again, I do wish I had an on-off button instead of just an unplug or plug it in, but it's not too bad of a price point for what it's doing. I am going to leave a link to the file in the description below if you would like to try to make your own, but it will save you a ton of time in prototyping and R&D to do this yourself. It did take me quite a few hours to figure it out overall with the 3D modeling and everything associated to that. So I did use SolidWorks Maker for this. I paid for it. I'm trying it out. I also have Fusion 360, but I'm trying out SolidWorks Maker because I use SolidWorks in my day job and I know how that works. It was a lot easier to transition for me for doing sheet metal bends and things like that. So we'll see how it works. I think it's $99 a year if you want to try it, but just wanted to give you guys the information on what I was using. But that's gonna do it for this video. If you enjoyed the video, give it a thumbs up, subscribe to the channel, and turn on notifications so that you know when I come out with new videos. If you'd like to see more projects like this with acrylic bending, or if you have other bracket ideas for the wall control system, put those in the comments below and I will do my best to make projects around those. But I want to thank you for taking the time to watch this video, and I'll see you in the next one.